Yeah, it should record everything that I do, and then I can post it on YouTube. In case you're just needing some entertainment, you can. All right, so this is supposed to be an equilateral triangle. If I mark it like that, you can accept it as true. And then these then are 60 degrees. All angles equal, all sides equal. The idea of this special right triangle, this first one that I'm going to go to, is that if you sliced this in half, it's called an altitude, then it makes a right angle there. If I pull this triangle out and work with it down here, then say I label this side X up here, then we'll call it X down here. This is still 60 degrees, and this is 30 degrees. And because of the properties that this triangle has, you can have less information and figure out the lengths of sides. So here's the idea. When you slice this triangle in half, you slice these two pieces. So this is half a side, and so is this. So in this triangle down here, I have half of, my original equilateral side. So the idea is what goes here. That's what we want to figure out. And there's a special relationship so that if you're only given one side length in this special triangle, you can find the other two. If you know, bless you, that it's 30 and 60. So the idea is this. Pythagorean theorem, if I square my sides, and I'll just put a question mark here. And my question mark squared, that's going to equal my hypotenuse squared. That's what Pythagorean theorem says, and I want to solve for my question mark so that I can figure out what I would have to do to whatever that side length is to find that leg. So this common denominator would be 4 if I change this into 4x squared over 4. And this is just plain old x squared over 4, and my question mark squared. Then if I subtract this from that, the square of my question mark is 3x squared over 4. So then Pythagorean theorem says if I want to know what the question mark is, you just square root both sides. Square root it all. Yeah. Because when you square, it's side squared plus question mark squared. You've squared both these things. Okay. Yeah. Great question. So then, here's the thing. It'll get written in this way. I can square root the 4. That's 2. So I'll go ahead and do that. I can square root x squared, right? The square root undoes the 2, so I just get x. The square root of 3 is a never-ending, non-repeating decimal. It's called an irrational number. That is what it would look like. That's how they write things on the SAT. That's how they write things on the ACT. And I just want you to get used to seeing square roots and things. So now I know what my question mark is. So I can get rid of the question mark. And I can put that this is x. So it's this side times the square root of 3 cut in half. Mr. Agamite may have given you the triangle in this way. So let me give you both of them. He may have said, well, because it's a little bit easier to digest. So this is 60 degrees, this is 30 degrees. If this is x, actually let me use something else so that it doesn't get too confusing. Say that this is it's a side length. Then I double this. And if I multiply this, whatever it is, by the square root of 3, these are the same thing. It's just one has the fractions and one doesn't. This one with the x flows through the proof more easily. This one I think is easier to. All right, so whichever one you're used to, that's what you All right. I'm going to stop this, and we'll try a couple of them